All right, here we go. A is parallel to B, so we're doing 9. I think we're also doing 11, and we're also doing 13. So I'm doing 3 proofs for you here. A is parallel to B. We're going to prove 1 is supplementary to 3. Write down your given. So I'm going to mark that using my little parallel marks like that. A is parallel to B. So now that I know that they're parallel, I'm trying to get 1 supplementary to 3. So I'm trying to get this one sup to this one. We're actually not going to use 4. You could, but there's a couple different ways to do this one. First thing I would do is I would get 1 congruent to 2. Right? So angle 1 is congruent to angle 2. So think about why. I would say if vertical, then congruent. Three is also congruent to 4, but we don't need to know that necessarily. So now, since they're parallel, I can get 2 sup to 3. 2 is sup to 3, and the reason for that is, so 2 is going to be supplementary to 3. And the reason for that is, if parallel, then same side interior, angles are sup. So now here's what we got. 2 and 1 are actually the same angle, so we can replace 2 with 1. So instead of saying 2 is sup to 3, we can replace 2 with 1 because 1 is congruent to 2. So we can say angle 1 is sup to angle 3, which is what we're trying to prove, right? And think about what we used. Well, we took 2 and we plugged it in to 1. Actually, we worked backwards. We took 1 and we plugged it into 2. Whenever you plug something in, you're using the substitution property. That one's done. Nice. For sure that'll be on that quiz, so let's get to know that one. All right, here we go. So this one we're using some parallel lines, and we're also using some bisect, right? So let's get PR is parallel to TQ. PR is parallel to TQ, so we're going to mark it like that. So what I would recommend doing, and it doesn't really matter how you do it, there's a couple different ways to do it. You can get your vertical angle. Some people look at this and they love the vertical angle, right? No, you can't call it angle S, but you can get vertical angles. What I would do is I would extend my lines, and then I would pick a transversal. So this particular one's nice because it doesn't matter which one we pick. So I'm going to pick this one. So if I extend it up here, it would look like this, right? And I can get angle T actually congruent to angle R because of alternate interior. Angle T is here. Angle R is, T is, my bad, it's not there. It's here, and R is here. So you can see those are alternate interior. And for the same reason, Q is congruent to P because of alternate interior. So I don't care which one you do. You can do them both if you want to. There's a lot of different ways to do this one. So we just found P congruent to Q. And again, we can call it by one letter because there's only one letter at that vertex. There's only one angle at the vertex. So we can call it angle P is congruent to angle Q. Because if parallel, then alternate interior angles are congruent. So now you could get T congruent to R as well. Or you could use vertical angles. It doesn't matter what you do. So I'm actually going to get T congruent to R for the same reason. Because if parallel, if you wanted to, you could say PSR is congruent. I'll write it here. Angle PSR is congruent to angle TSQ because of vertical angles. But you don't need that because we just need 2 angles, and you can't get triangles congruent by angle, angle, angle. So you need just 2 angles. Now look at this. PQ bisects RT. So RT is the thing getting bisected. PQ bisects RT. So we know that RS is congruent to SR because RT is getting cut in half by PR. So we can go TS is congruent to SR, because if bisect, then congruent. And now when you look at it, you can get the triangles congruent to each other. PRS, Paul Reed Smith, is congruent to, I don't know, QTS. So it could either be angle, 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 side. Or if you use the vertical angles, it would be angle, side, angle, depending on which one you use. So if you have vertical angles in there, you're going to use angle, side, angle. If you did it the way I did, you're going to do it with angle, angle, side. Okay? Cool. Last one. SO is parallel to PU. So SO is parallel to PU. So we're going to extend that, and we're going to extend that. And those are going to be parallel to each other. So now if I make this the transversal here, I'm going to get two congruent angles, and I'm going to get two angles that are not congruent to each other. When I look at this, I see that this angle here is congruent to this angle here because of, again, alternate interior. They're both on the inside, and they're alternating across the transversal, right? So that's what I'm going to do next. I'm going to get, again, you can't call it angle O. This angle and this angle. You cannot call it angle O, but you can call it by its three letters. Let's spell it out together. SOP is congruent to OPU because if parallel, alternate interior angles are congruent to each other. We know this right here, so that's going to be my next statement. OU is perpendicular to OP, and SP is perpendicular to OP. So SP is perpendicular to OP, and we also know OU is perpendicular to OP. So we can get those two angles to be right angles. If they're perpendicular, that means that they form a right angle. So I'm going to skip a line here. Angle UOP and angle OPS is right. I guess you would say are right. And the reason is because if perp, then right. And not only are they right, so now that they're both right, they're congruent. And then finally, we got two more steps here. Actually, we have three more steps. This is kind of a long one. We can get OP congruent to OP. That's Jenna's favorite property, the reflexive property. And now we can get the triangles congruent. Triangle UOP is congruent to triangle SPO because of angle, side, angle. The side is between the two angles, so it's going to be angle, side, angle. And now that the two triangles are congruent, their parts must be congruent as well. So we can go SO is congruent to UP because of CP, CTC. There's a throwback for you. Corresponding parts of congruent triangles are congruent. All right, there you go. Hope that helped. Peace.